Welcome to the Science Slam at the 14th Global Forum for Food and Agriculture. I send many greetings directly from this great studio here in Berlin. My name is Insina Lüschen and I'm so grateful that I'm able to host this Science Slam for the second time already in this hybrid format during this global pandemic. And I say welcome to all of you from wherever you are watching right now. It's great that you are with us. This year, everything is about the topic of sustainable land use. And our four candidates, with their presentations, will talk about their research concerning this topic. So, yeah, you can look forward to four presentations of candidates I will soon introduce to you. But first of all, I will ask from where are you watching, because that's an international Science Slam and we are here from all over the world. Even our candidates are from a lot of countries and continents even. So we organized a poll and we are really interested. Maybe you can participate at the poll. When you are registered and leave the full screen, you will see at the right side a bullet and a question. Where are you watching from? And you can choose your continent so that we can see how international we really are today. So please register if you haven't done it yet and participate at the poll. Later on we will have the results. Have fun with that. And now I'm really glad to be able to introduce to you guys our four candidates. And they are here on this great screen in the bar. Welcome to Pamita Gosh, you are sitting in India. Welcome to you, and welcome to Moritz Nagel in Germany, and to James Gacheru Ranjiku in Kenya, and to Lev Maximov in Russia. It's good to see you. And the internet connection is there, so we can be in touch with each other. Good to have you here. We will see you soon, but I am not the only one who wants to say hello and welcome. So there are some greetings in a little video from our new Federal Minister of Food and Agriculture, Cem Özdemir.
Ladies and gentlemen, I would like to welcome you all at this year's GFFA Science Slam. I thank all slammers for their willingness to share their passion for research with us. What distinguishes a Science Slam is the presentation of complex scientific topics in a lively and entertaining manner. The aim is to convey scientific facts as entertainingly and clearly as possible. A Science Slam inspires fascination with science. This is what makes the Science Slam perfect for our GFFA, because we want to enter into an exchange with brilliant minds from all parts of the world to develop innovative, research-based ideas and solutions. And conserving and protecting our soils is right at the top of this year's agenda, as food security starts with the soil. Our soils are one of the most valuable resources for food production. Soil is a habitat for a large variety of macro and microorganisms. It also acts as a water reservoir, and it is the Earth's most important terrestrial carbon sink. By protecting our soils, we can make an important contribution to global food supplies, to combating the climate crisis, and ultimately to biodiversity. Our creative young scientists in the Science Slam will also be presenting their research on sustainable land use and soil conservation. Because research and innovation can and must help develop scientifically based and practical solutions for the global challenges. And the particularly exciting aspect of this is that these four up-and-coming scientists will be joining us from 4 countries in very different parts of the world, namely from India, Kenya, Russia, and Germany. I'm looking forward to your research presentations. I would like to thank you once again for taking part in the virtual GFFA Science Slam, and I wish you all every success. And to all those watching from across the world, I hope that you enjoy the event, an exciting online vote and a stimulating exchange with the slammers. And the winner will be sent our ministry's prize, the popular GFFA Science Slam trophy. Thank you very much.
Thank you to Cem Özdemir. And for you candidates, take a deep breath. It's your turn pretty soon, so break a leg from here. And now, I'm really interested. I have the results of the poll. You participated, that's a good thing. Keep in mind how you did that, because you need this technique later on to vote. What exactly that is, I will tell you soon. But now I can see there are a lot of people from Europe. 93.1% from Europe. So there's no much percent over for the other countries. So it's from Africa, 6.9%. So a warm welcome to all the people in Africa. And now you need to call all your friends in America, Asia, and Australia, because they are not even here with us. So make it more international, call them all. So let's have fun here all together. But especially to you, really a warm welcome. And now it's time to talk about you, the audience, because you have a really pretty big job today. You're not here just for fun. So just that you know, it's your part to vote for your favorite slam presentation. And for the candidates, it's good to know there will be a winner at the end of the Science Slam, and there is a trophy who goes to the winner. And how this trophy looks like, you can see in this little trophy clip. Now you know it's worth to give everything, so you can get this trophy at the end. Now it's up to you, and maybe you ask yourself, and how do I vote, and how do I decide which presentation I like most? Well, here are some criteria you can use and keep in mind while you are watching to these 4 presentations. Maybe you ask yourself some questions. Did you understand a word? Was it somehow interesting for you? Did you understand why there are research funds given for such a research? How was it presented? The rhetorical skills or mimic and facial expressions? And most of all, did you feel the passion of the Science Slammer? Maybe there is even a cat picture in the presentation and in the PowerPoint, or maybe even 2. You can make your decision for your favorite presentation. And in the end of when you listened to every 4 candidates, you can choose your favorite presentation. The technique is the same as you used during the poll. So get registered if you haven't already done that. The most important thing for today is keep in mind that these candidates are sitting in their offices or kitchens or bathrooms even. And it's really a tough thing to talk into a camera or a cell phone and to get this energy to you and not having the real audience in a direct response here on stage. So please, we need you. We need your full love and all your enthusiasm and everything, your whole energy, and you need to send us directly to this stage and to every single slammer. So put it in through the internet directly to us. That's really important. Be with us with all your energy. Thanks to that in advance. And now let's get it started. I'm really glad to introduce to you our first slammer here on stage. It's Lev Maximov from Russia. He did his Master of Science and his PhD at the Industrial University of Tyumen in Russia. And he is a board member of the Club of UMNIK and a member of the Civic Council in the Tyumen Regional Parliament. And he is an engineer and junior researcher at the university. And he is the founder and the CEO of the Firm Group, a startup company. Wow. So it's really good to have you here on this hybrid stage. And I say, enjoy your time. See Lev Maximov.
Hi, everybody. Probably I can start because we already knew about me a lot, and hopefully you would know about my research quite a lot. I try to be not really boring today, and we will start with our global goal. It's soil sustainability increasement. But the tool we would like to use, it's nanomaterial and it's mass obtaining. How can we connect these two maybe really different things? Our tool, second tool, is groundwater, and it's polluted wastes from this treatment process. That's why it's soils 11. And now we know about, we would know about top useful groundwater components. Firstly, let's see me at 2015 in my own birthday. Yeah, standing in the lake because it was the first topic of my research interests. After that, it was iron-containing groundwaters, and only after that, it's groundwater treatment plants wastes recycling into something useful. But what purposes for me to research all of this? From the very beginning of my education in university, I strive to know how to make our lives better. Not only in my hometown, Tyumen. It's in Siberia, we have a lot of water and everything's good. But I know that in Africa and in a lot of other regions, we have really big problem for water. And maybe you agree that our Earth, our lands, it's a kind of treasury, the world with enormous slots of everything and everything useful for us. But we have to know how to extract this. So where is all water? As you can see, only maybe 2 or 3% are fresh water. Everything else, it's oceans and seas. So that's why Ocean's 11, maybe you saw this film, it's not our option today. Our option today, it's Soils 11, because iron, sulfur, zinc, and etc., we can extract from the groundwater, because about a third of all fresh water in our Earth, it's really underground. If we can see on Africa, you can understand that really arid regions are really rich with underground water. But we have some big problems with extraction of it. The main challenges are it's sometimes too polluted for filtering or too deep to extract. And in these pollutions, we have a lot of mineral components. But what do we have if we would know how to recycle it into something useful? Our solution is when these factors involves, we product out of these wastes, metal powders and fertilizers. But firstly, we can look at plants, groundwater treatment plants wastes recycling into iron or iron nanopowders and etc. and etc. In Russia, you can see the numbers. It's quite big. And even in Berlin, we have about a ton of this per day. It's maybe not really big for some kind of heavy industries, but for micro and nanoscale resources, it's really, really good indicator. You can see on a micrograph that's we have spherical parts about 100 or even 200 nanometers. It's much, much less than thickness of our hairs. Probably for this situation, everything is already good, because out of this wastes, we can produce a lot of things, just like batteries for renewable energy, catalysts, and even for additive manufacturing, some metal powders. And it's look like really kind of snowball. Maybe it's mission completed, everything's okay, but today we're gonna talk about soils. So our problem, it's not only to recycle the iron out of these wastewaters, but we can't forget about any other metals. Sometimes it's up to 60 or even 70% if we despite the iron of this amount. So when we would like to produce iron nanopowders, we face some problems. The main of them is PM2.5 pollution risks. And when we thought we need to deal with this problem, then I don't know, insight goes in our minds. We should use this wastes from recycling of waste really like a team to save our world and our soils, because everything of this may be really useful for us. You know that agriculture of today is really big landfills. We use a lot of fertilizers that's extracted like mining and etc. And it's not really pure and ecological. But when we talk about agriculture of tomorrow, when we talk about maybe hydroponic plants and etc., we still okay to use some not really mass, but really small for this amount and small for pieces prices, for piece sizes, these fertilizers. So as you can see on this micrograph, it's okay. For application of this system, we have circular economy tools. In this scheme, you can see that after all preparations, we have more clean urban water for urban, for rural areas, and this waste total removal and recycling. And after that, we have metal powders for any other reasons, and a lot of fertilizers from the things I have already mentioned. When we talk about sustainable development goals, we have really bunch of this. Not only clean water and sanitation, but everything related to clean energy, to well-being, to soils, to ecology, and etc. and etc. The second really important thing that we have a conception of autonomous cities. When the first stage is already done, it's okay. Food supply via these hydroponic plants, it's quite okay. But raw material, even for production of fertilizers inside of the town, maybe not using some big amount of landfills around us, it's a really big problem now. We haven't solved this problem yet. So our goal for next 20 years, as I think, for our team, for maybe our professional community, is make tool to create not only iron containing nanopowders, but cobalt, nickel, and etc. So get rid of it from the water we drink, and this would be really useful for billions of people, for thousands of infrastructure objects, and I think it would be really a good push for local industries. So as we understand, the Earth needs and awaiting for sustainable solutions for water and soils. We can't separate sustainable soils and sustainable water. It grows and goes only together. So let's provide them together and making new ways how to make our planet better. Thank you very much.
Thanks to you, Lev Maximov in Russia. Whew, you can relax now. It's over for you. You can just enjoy the other ones. And I'm really glad that we can go on with James Gacheru Ranjiku. He's sitting in Kenya. I hope the connection is there. Yes, it is. He did his bachelor in horticulture at the Jomo Kenyatta University of Agriculture and Technology, the master and the PhD in international horticulture at the Leibniz University in Hanover. And now you are a lecturer at School of Agriculture, Earth and Environmental Science in Kenya as well. And you are talking about alien plant, foe or friend of land reclamation. It's good to have you here. Don't worry, we have a movie of your Science Slam presentation, just in case the connection is not working so fine, but it's great to have you here. So enjoy yourself, and we enjoy your presentation. Welcome on this hybrid stage, James Gacheru Ranjiku.
Hello and welcome to this presentation on alien plants, whether they are friends or foe, when it's come to land reclamation. I'm your presenter, James Ranjiku, from Taita Taveta University in Kenya, the southern part of Kenya, what we normally call Coast Region. So, alien plants, friends or foe in land reclamation. When we're talking of alien plants, we are talking of plants that are not native or that do not originate from that particular region. It could be within the country. It could also be outside the country. For instance, here we are talking of Italian plants that are of the same species, but then originating from one region and then heading to another or being used to another region. We could also be talking of plants originating from within the country, from one region and being moved to another region. So in this case, we are talking of North Rhine-Westphalen, or sometimes we shall see later other provenances, and Brandenburg are also originating from east of Germany. And our essence here is to find whether they can survive the soils and climate of Niedersachsen. So if these plants were taken to Niedersachsen, could they grow there? Could they survive? Could they perform the conditions in Niedersachsen? Would they be different? So for our plants to perform differently, we took samples from Brandenburg, then land France. Of course, this is the northwest of Germany, and some of the species came from the south, from other country, in this case, Italia. So, and how did we qualify this plant? We qualified this plant to be native in that region, in that country, historically, by looking how many years this plant have stayed there. If the span is over 50 years, then that plant qualifies to be a native species or a native plant or a native ecotype in that region or in that country. So we took samples from North Rhine-Westphalen, Brandenburg, Italia, and other parts of Germany. And we took these plants to Hanover, that is Niedersachsen, and we wanted to find out whether this plant can survive. Of course, the climatic condition of Niedersachsen, can they survive the winter heat? Can they survive the summer heat and the winter cold? And will they be able to defoliate their leaves early enough? Or will they delay the defoliation of the plants when it comes to fall? So, of course, we saw that some of those Italian ecotypes of plants were delaying leaf fall and, of course, defoliation of leaves. And they also, when it came to spring, they were able to sprout early. The Italian ecotype were forming new leaves early than those of the German ecotypes. But the most great thing is that they were able to survive the summer, the fall, and the cold winter of Niedersachsen. So they were able to survive, and this was very important, indicating that they can indeed survive those areas, even if it is not their origin. So this is an example of plant, how they look like. But we checked also on internally how the plants were able to resist the cold, to resist the summer heat and the summer drought, and how sometimes they were able to resist the spring cold. Of course, we know that young leaves are very prone to cold, and so how are they able to survive, especially the Italian that were forming the leaves early? So we tested the inside, of course, how the plant react when it is cold, when it is lacking water, when the heat is high, how do they survive? We check some of these physiological parameter or internal reaction, like a human being, how we react. When it is cold, of course, we shiver. Or when it is hot, of course, we sweat. But now the plant do not do these things, then how do they do it? So we also check the damage, whether the plants were damaged, they were dying back or drying. That would be a sign of damage. And also we check biochemical, what is it that they're able to produce? And the things that we check are the glucose, the fructose, the sucrose, and the starch. Are they able to make extra amount, extra concentration in them to protect them from cold, from drought, and so forth? We also check the proline, and we also checked other things that we might not mention in this presentation. So these are the things that we're looking into. So we were looking inside the plant. Of course, the plant does not take jacket. So how do they do it? So we were taking samples from shoots, and these shoot samples were taken from different plants, combined together to make a composite, mix together samples, and these samples were the ones that were used to analyze those glucose and the sugars and protein. In addition, we are taking on the nutrients. How are they able to make use of the available nutrients? Are they able to take up more? Of course, taking up more can help the plants also make more food, and making more food means also they can able to convert more sugars and more protein for their protection when they are needed. So we also talked in spring, there some plants were forming shoots or new leaves early, and also we checked the same parameters. This also was done in summer as well as in winter. So how did they survive the climate of the Kazakhstan? Of course, I've already talked in summary what we were doing, the analysis, and they were able to survive by making proteins, more proteins and more sugars. That means for them to survive in those areas, they are able to react inside. It's like us from Africa. When you come to Europe, we normally take on heavy jackets, so that because we are not used to cold. The winter, we are not used to winter. And that means then the plants were able to take more of these proteins, manufacture them within themselves, and this one that were helping them to keep warm. Of course, even when it is summer, like normally sometimes in summer, we take off clothes, of course, light clothes we wear. And this is also helping the plants to retain more water because, of course, the plant do not sweat. And this helps them to protect themselves against excessive heat or excess or lack of water. And this is the two plants that I was dealing with, the sloe or Prunus spinosa and the hazelnuts, the Corylus avellana, are good example in Europe that are used in highway planting, or sometimes used in land reclamation where mining has been done and you need new plants. So they are planted there, of course, with other uses. They help in the creation, they help the birds to nest or to get food, the squirrel get food, and so forth. And we have a plant in Africa originating from native from South America, the Prosopis juliflora. And this particular plant is very handy when it comes to arid and semi-arid areas of Kenya. They help protect the soils against soil erosion, that is washing of the top soils, that will be useful when it comes to production of crops, of foliage for the animals. The pods themselves from this particular plant are also useful for animal feed. The goats, the cows, they eat. Of course, we know we don't keep our goats and our animal or our cows out inside, like in Europe, but we let them go roam in the environment so that they can feed for themselves. And this plant, it has been found to be very useful when it comes to protection of the soils in climate. So when it comes to allium plants, do we consider them as friends, or would we consider them as 4? So to us, the plants that I was dealing with, the Prunus spinosa, the Chlorella salvulana, and now the Prosopis, we consider them as friends to our land, as friend to land reclamation, as friend to soils, because they will take you along the path to protect the soil and also provide food for the livestock, in our case, the Juviflora Prosopis. Thank you, and I'm ready for your questions.
Thanks to you, James. Thanks to Kenya, and a special thanks for preparing this video so that you are here with us today. So you can relax and stay with us. Later on, we will see who the winner is today. And now we have the third Science Slammer already. I'm looking forward to see Moritz Nabel on this hybrid stage. He studied at the University of Hohenheim, International Master in Crop Science and the Bachelor in Agriculture Biology. His PhD he did at the Helmholtz Research Center in Jülich, special field, plant science. Now he is a scientific officer at the German Federal Agency of Nature Conservation, and he is proclaiming, our system has a bug. Let's make use of it. So welcome to you, Moritz Nagel, on this hybrid stage. Go on, it's your time.
Well, thank you, Insina. Well, what I want to do is I want to take you on a journey below ground to discover the hidden half of agriculture. And as I'm not native to this environment down there, I brought a tour guide. This is Fai, the earthworm, and he will be our guide. Fai, you want to introduce yourself? Unfortunately, he doesn't want to talk because he thinks his earthworm accent would sound even more stupid than my German, but yeah, apologize for that. Well, when we think of bugs in agriculture, we usually think of nasty fellas like here, the potato beetle or the grasshopper, or maybe also aliens that come to our fields and destroy them with their weird and stupid circles, attracting hundreds or thousands of tourists. But as I mentioned today, I want to change the view and take a look below ground. So let's go deep. Wow, that's dark here. So safety first, because 90% of the organisms down there are not discovered or described yet. So maybe they're dangerous. Be careful. So let's turn the light on. And what we first see are roots. Well, roots are nice, but they are not bugs. Well, you're lucky I brought my magnifier, so maybe we zoom in a bit. And what we see first here is Mycorrhiza. Mycorrhiza are a symbiosis between the roots of our crops and fungi that gives them better access to nutrients. Or here, another symbiosis. In these small little nodules, that's the habitat of rhizobia bacteria. And they give our crops access to atmospheric nitrogen, well, very helpful for us. Or here, these two fellas, Nitrobacter and Nitrosonomas. What they do, well, obviously they have a good time down there, but you think it's beer they're drinking? I have to say no. Actually, it's cow pee, because what they do is they convert urea into plant-accessible nitrate. Also perfect for us and agriculture. And obviously, they enjoy their job. So thanks, guys. Well, let's zoom out a bit and look for some bigger organisms. Like here, this beautiful Springtail. Again, it seems he has a really good time and good food. And again, you think this is a conventional burger patty. No, it's not again. It's more a cow burger patty, let's say. And obviously one of those is enough for several of our Springtails. So he invited some friends. And don't you think they all look crazy and beautiful in their own way? And take a look at this fella up here. Maybe you recognize him because I introduced him earlier to you as alien. And because what I think is, what is really interesting for us humans on Earth is not extraterrestrial life. What really has an effect on us is intraterrestrial life. And that's where the real crazy species live. Maybe I can introduce some to you, like here, these micro snails with their crazy houses, or these mites. I guess it would be easy for them to get a major position in the next Star Wars movie. Or here, parpods, microscorpions, and even Fai's friends, the earthworms. But have you ever seen this other worm fellow down here? I guess not. So you might ask the question, yeah, they are nice, but why why do you introduce them to us? Well, the first reason is very simple, because I think these creatures, they are beautiful, and more people should be aware of these creatures and should know them. If you also think so and would like to learn more about them, I highly recommend this webpage, chaosofdelight.org. Andy Murray, a very good photographer, did a great job in taking all these pictures of soil organisms and gives some additional information. So go and check it out. Well, the other reason is more related to the topic of GFFA, and it has something to do with the party that is going down there. Because, yeah, it has something to do with cow patties and cow beer. Because if microbes wouldn't take care of it in our soils, during shortest time, we would be completely covered with this. And I don't want to live on an earth that's covered with cow patties and cow beer. Second, it also has something to do with our food production and our well-being on Earth. The FAO last year published this nice overview of all the sustainable development goals, of which fulfillment, obviously these are too much for a 10-minute talk, so I thought in the face of GFFA, I would narrow it down to SDG 2, zero hunger and food production. So what soil organisms do is they provide a good soil structure that allows good water infiltration and water retention, and then gives plants access to water also in drought periods. And as I already mentioned before, they are responsible for carbon and nutrient turnover and make these nutrients plant available. And they also take care of our wastes and all the toxic substances that we pollute our soils with. So all in all, we can say soil organisms are the guards of soil fertility, and by that lay the basis of all agricultural activities on our Earth. Well, you could say, nah, that's not possible. We are 8 million people, we are messing it up. How is it possible that these tiny organisms, they take care of all this? Yeah, they are tiny, but they are many. If you just take one spoonful of soil, there are as many microorganisms in there as we are humans on Earth. And you can also put it in the context of biomass. So let's take a defined area, a soccer field. We know the biomass above ground, and 22 players, a game which is more or less complex. But if we take the very same area and look from below, microbes and soil organisms have an equivalent biomass of 122 football players. That's impressive, and you can imagine this game is much more complex. Yeah, you could say, well, thanks to organisms for doing all that great job. Where's the point? The point is, we are losing it. We are losing biodiversity in our soils, and by that we have problems with soil degradation and desertification. And this illustrates also this map here. In red, we see all the regions in which soil organisms are threatened and under pressure. And if we overlay it with the map where we have intensive agriculture on our Earth, well, we could say soil organisms are especially there threatened where we depend most on the ecosystem services. If we just look at this tiny region up here, it's called Europe, by the way, the ecosystem services provided by soil organisms related to agriculture are worth 38 billion euros, a really impressive number. And I think it's time we give something back to soil organisms. We have to pay them back. First, we could simply take the money, throw it on the ground and say, take it. You know what soil organisms do? They do what they do. They come, they degrade it, convert it into burger patties and have their standard party. Obviously, this party would be pretty expensive, so maybe there are better ways to support them. Yeah, they are. Starting with fertilization. Our fertilization is orientated only by the crops, but we also need to apply carbon to our soils to maintain soil life, because carbon is the energy source for all these organisms down there. Then it comes to soil compaction and intensive tillage. Obviously, by these practices, we completely destroy the natural habitat of the organisms that we depend on. So we should go more for direct and mulch seeding systems. But please don't use it as an excuse to apply more and more pesticides, because these toxic substances, they accumulate in the soil and destroy the habitat again. Instead, we finally should get the concept of integrated pest management running. The FAO is promoting it already for decades. So yeah, just do it. And last, awareness. Be aware of how you treat your soils and what you do to it. So get out of your machines, get dirty. It doesn't necessarily need to look like here on this picture, but at least touch the ground, feel it, smell it, and get your hands dirty. Because like this, we can turn soil into a respect zone. Humans tend to only respect what they really know, and that's why my colleagues and we put some effort into writing a report on soil organisms and their contribution to agriculture. Unfortunately, this report is only available in German, but we also published peer-reviewed English shorter version in the Journal of Soil Organisms. So if you're interested, please go and check out these publications. And please, next time, speaking of respect goes also to all these people that let me use their pictures for this presentation under Creative Commons. And yeah, next time you eat or drink something nice, please pay some respect and think of where it comes from and who did the job in converting it into something so delicious. And with this, I want to end, and thank you very much for your attention.
Thanks to Moritz Nagel. Thanks for this presentation. And now you can take another deep breath and relax. It's over. And maybe the trophy goes to Moritz Nagel. We will see in a few minutes. But now I'm really glad that there is, last but not least, Pamita Gosh from India. She did her bachelor in agriculture engineering at the university in India, her master in geoinformatics at the Indian Institute of Technology in Bombay, and she was an India research exchange student at the Technische Universität in Darmstadt. And now, Pamita, you are a data scientist in Hyderabad in India, and you work for Corteva AgriScience. It's really great to have you here, so enjoy your time. Pamita Gosh in the Science Slam at the GFFA.
Hello, everyone. I am working as a data scientist and developing different data science solutions for agriculture. And today we are going to talk how cloud computation and the power of a mouse can help us to achieve sustainable land use. We can see here that most of the continents, the soil falls in very degraded to degrade category. And they are the real heroes and anchors for the food production. And every minute, 17 hectares of soil are sealing. And most of the Asian, Europe, and Eurasian, and East and North African soils are in poor to very poor condition in terms of soil sealing. That means we are losing our valuable soil and agricultural land, whereas the population growth is increasing from 2 to 3% in every continent. That means there is a growing crisis of food security. In 2019, 135 million people across 55 countries suffered from this problem. And we have our frontline fighters of this problem. They are the farmers. And today I have with me one such farmer named Chasha. So today we would like to learn from Chasha what his problem is and how he is trying to feed us with the growing crisis of soil degradation. Hello. Hello, Pamita. How are you doing? I'm good, Chasha. Can you please tell us how amazingly you are feeding us in spite of all the challenges you are facing? Oh, Pamita, thank you for acknowledging my efforts, but I do also sometimes feel helpless. I am the 4th generation farmer, and I inherited the knowledge from my ancestors. But sometimes this climate change and uncertainty of weather is really putting me in stress. And the farm input costs are going really high. So sometimes I also wish if I can get some kind of help or assistance to grow the crops better and also harm the environment lesser, that will be good for me. Oh, Chasha, thank you for telling us your problems. I think geospatial technology can help you solving your problems. Pamita, what is this technology is? I have never heard of or come across such kind of technologies. Oh, Chasha, geospatial technology is the technology which enables us to collect and analyze and interpret the data from Earth's surface. And we can use the different information from Earth's surface to really help you. Oh, really? Yes, Chasha, we can. Here, we can use different kind of Earth information like land use map, and we can actually analyze how the land use pattern is changing across the years. Oh, Pamita, you have took the right thing. You know, my farm holding is decreasing due to urbanization and degrading soil quality. Yes, Chasha, we can analyze the hotspot of these problem soils and we can come up with alternative solutions. And we can also analyze different years across the year crop yield map and also the crop nutrient and soil nutrient status and disease pest history, pattern of weather, and can develop a data science solution, which is this neural network you are seeing here, and suggestive farm management guideline for sustainable land use, which will help you to optimize your farm operations, maximize your yield, and also farm sustainably and profitably. But, Pamita, how can I trust these machines when sometimes having the knowledge of my own piece of land, I fail to make the right decision at the right time? How can I rely for my field to a machine suggestion? Oh, Chasha, how, if I ask you, how do you make decision for your farms? I take decision from my knowledge, and also I see how the trends are going in agricultural science, and then I take the best decision. Yes, exactly, Chasha. This neural network, this data science neural network exactly mimics the human brain systems. Like in human brain, you decide based on your past experiences and the current observation you make. Your neural network make all this decision in your brain. Similarly, this neural network is also taking consideration of all the possible controlling factor of farming and suggesting you the best options. And moreover, you are using your knowledge, your neighbors, or your fellow farmers' knowledge. Here, with the help of geospatial technology, we are looking at the larger picture from different parts of the world and learning the patterns of soil quality and the possibility of growing crop with those qualities and the possible pest and disease occurrence in your field. And all these patterns are learned by this neural network and finally suggesting you the best possible measures. Oh, Pamita, can you please elaborate more how you will know that what the weather will be? Weather is the most uncertain parameter, you know. Sometimes the forecasting here, I really don't get. And sometimes for soil dryness or soil moisture deficiency also, I see the forecasting is wrong in order to what I see in my field. Oh, Chasha, that's where this intelligent data science network is working. We are analyzing a lot of data, which is called big data. We are using historical understanding of the weather, and based on that, the weather predictions are made, which are more than 90% accurate. And we are understanding the pattern of your soil and the trends, which has it gone through across different years, and bring you the best possible solution. Okay, Pamita, now I understand your solution, but can you tell me how it will be sustainable? It might be profitable for 1 year, and how I can ensure it is good for other year too, and also the cost of farm chemicals are really going high and damaging our environment. How can I really feel helpless when I have to use it, but I have to use it to prevent my crop. So how can you help here? Yes, Jasha, in this recommendation or management guide, we will also provide you the minimum farm or chemical input requirement, which can help replenish your soil quality and make minimum damage to the feed. And overall, all these components together will give you the best possible solution to understand from. And this data science is taking care of the different kind of scenarios in the field. And based on this, it is learning what kind of input will be sufficient to gain your maximum yield, and also understand the current and the predicted weather patterns to give you the best possible recommendation. Okay, Pamita, now I can safely say that scientists and farmers together can achieve the mission of sustainable land use. Yes, Jasha, we can. Thank you.
Thanks to you, Pamita, and thanks to Jasha, of course. That was your premiere and you made it. Relax now. And now it's your turn. It is voting time. So you have the responsibility to vote for your favorite presentation now. So be nice and careful. I hope you are registered by now. Leave the full screen and you will see the question and you can decide which presentation you like most. The results we will have in a few minutes, and till then I'm really glad that we have all 4 candidates on screen again. Good to see you all together now on screen. It's celebration time already, because it's just good that you were with us and that you were part of this Science Slam, no matter where the trophy goes later and who the winner really is. Pamita, I start with you. That was your premiere. How was it on a hybrid stage to make a Science Slam?
It was a nice experience, but I wish I can feel the energy of the audience too.
Yes, I believe you. And I can tell you, with an audience in the same room with all the candidates, it's ecstasy. But maybe next year or whenever. Thanks for being here so far. Moritz Nabel, thanks to you again, and greetings to Bonn. If you are the winner and the trophy goes to you, do you have any idea or a spot maybe where you will put this trophy so that everyone can see it?
Yeah, I think yes, because I mean, I presented the work, but obviously many of my colleagues contributed to collecting all the information that I presented. So yeah, I will bring it to the office and share it with all the colleagues that also deserve it.
Talking about respect, as you said. Yeah, of course, the same one. Yeah. And James, it's so good to have you here now. How nervous were you?
I must say that indeed I was a bit perspiring, sweating. But I thank God that I was able to share something with the Urban International, and I got this opportunity to share. So I'm glad and I'm happy.
Yeah, it's great to have you here. And talking about sharing, Lev, I know that you have already done some Science Slams, but why is it important to you to be part of Science Slams and to talk about your research?
because there is no losers. Everyone who gets the stage, who gets the spot and make something new about science, just talk for the really wide audience, is a winner for itself. For me, it was another one opportunity to let know more people how groundwater is really important to all of us. And frankly speaking, it was my first time when I was presenting in English without any plot, without any paper with me. So it was just me and the presentation. And the work of my team for last 3 years.
Yeah.
That's it.
That's it. And science communication is so important, especially in these times. But you said it pretty well. For me, every one of you is a winner today, but I see there is a winner voted by the audience, and now I'm really excited to who the trophy is going. So maybe we can see another clip and then we will know who the winner will be of this GFFA's Science Slam. Winner is, and the trophy goes to Moritz Nabel. Congratulations and party to everyone, and especially to you, the audience. Just celebrate, and a toast to you, just imagined, but it's great. Moritz, congratulations. And I ask you where the trophy goes, so now you really can share it. We will send it to you in a few days. You can send many greetings to everyone who helped doing your research. But to all the others, of course, a really great applause. And I hope you all can feel the energy from the audience. For here, it's really great. Thanks for all your love, and thanks for voting. So congratulations to everyone, especially to Moritz Nabel again. You can talk to everyone in the deep dive later on. There are directly after the Science Slam, the opportunity to choose the room where you can talk more specifically about this research and the topics with the Science Slammer. You will see the link, just leave the full screen and it will probably work out. So you will still be there asking or answering questions, maybe asking questions, maybe getting into a discussion. Enjoy yourself, celebrate, that's important, and yeah, have fun during the deep dive, and most of all, thank you for being part of the Science Slam. Another special thank you to everyone who organized this event. It takes a lot of people, and it's really important that it's really well organized. So thanks to everyone in the background, and especially thanks to all the event technicians in the background. You have no idea, it's incredible what's going up on there in the background. And thanks to all of you, it was really a great time, and we feel safe here on stage, and that's a good feeling. And now, thanks to you for tuning in, for being with us, and I, in Sina Lüschen, say thank you so much. I had a great time, and I hope that we will see each other maybe next year, maybe in presence. We will see. Until then, stay safe, take care, thank you, and goodbye. Mwah.